Thank you everybody for coming, and thank you for all those people that are joining me online as well. I'll just wave at them. I hope you're all okay, sat in your pajamas. We're all obviously here in Wales. I assume you're in your pajamas. As you probably gathered, my name is Paul Andrew. Apparently I'm a technical architect. I work within the Centre of Excellence team at Avanade. So that's tend to what I do by day. I'm a consultant. By night, I'm a MVP, and I do other things as a husband and parent and all that stuff. So we are here today to build a Azure Data Analytics platform, end to end, in 50 minutes. Who's up for the challenge? Yeah, right. Let's do it. Alt-Tab, Azure Portal, Clean Resource Group. What should we put in here? Helen, what should we build? What should we create? I'm teasing. I would love to build this for you in 50 minutes, but sadly, we can't. Not quite achievable. So we will do it the visual way. I'll try and tell you a story of how we can do this. Now, if you would like to take a copy of the slides that I'm about to show you, then there is already a PDF of them in this GitHub repository, so feel free to grab a picture of this one. Community events, subfolder for SQL bits and the location and things, so you're very welcome to take a copy of that PDF. This is pretty much the only one you need to take a picture of. All good? Awesome. So, our agenda then, in the 50 minutes that we have, because we are going to do this end to end, is quite simply this. Designing it, extracting it, transforming it, loading it. Because I'm old, I have lots of grey hair on my head now. I like ETL. I can date myself by SQL Server 2000 and DTS packages and some VB script that would rewrite those DTS packages with some metadata. All good fun. Any other fans of SQL Server 2000 in the room? A few people, okay, good, I'm not alone then. Let's do some design work then, shall we? Design's important, right? We need to design this platform before we build it. Yes, Paul. It's Saturday morning, maybe not. Let's start with a question then, an easy one. A question that I think you'll know the answer to. What is the answer to life, the universe, and everything? This audience knows the answer to this question, right? 42. Yeah. No. This is not the answer. I want to change history. The answer to this question actually is it depends. As a consultant, this is a far better answer to this question. So please go forth. I do like the film, of course, Hitchhiker's Guide to the Galaxy, and indeed the book, but this is a better answer to this question, as we will demonstrate as we go through today. So it depends, fine. Next question, what is big data? It depends, yeah? You get a bronze medal for that one. The answer I like, though, is this one. Any data that you cannot process in the time that you have or want, using the technology that you have. I like this answer. I heard this answer from Mr. Bookwoody, Microsoft Mr. Bookwoody. Do we like Bookwoody? Yeah. No, nobody likes Bookwoody. Everyone's shaking their head, Book. Oh, I'm so sorry. Not really. We love Book. So I heard this from Bookwoody. I like the answer to this question. And of course, now we've come to kind of distill this thinking around big data with a series of V's. Volume, velocity, variety, I think was where we kind of started out. It's extended now to veracity, the accuracy, and the value of that data. I think adding value is definitely a good one in there. So, this helps us, this informs our design of what we want to go and create. Okay. Next question then. What is the goal? What are we really trying to do here? We want to build this thing, but what for? Just because it looks nice? No. Ultimately, we have some data sources, And we want to get some insight from those data sources, to be data-driven, to be value-driven. And as I'm sure we know, data becomes information, becomes knowledge, becomes power. We want to be more powerful, right? Yeah, power. How do we do that? We need something in the middle. My magic box from Hogwarts? Of course not. You get my silly sense of humour by the end of this. I'm going to call it a data warehouse. I think it's okay to call it a data warehouse. Do we like a data warehouse? Maybe. You lot are obviously too scared to answer my questions. It's fine. So we'll call it a data warehouse for now. And absolutely, we will use that data warehouse very simplistically to gain insight from that data. You know, nice, easy, nice warm-up. And what we'll ask of that data warehouse typically is we'll want to clean that data, enrich it, transform it, you know, etc., etc. You've heard this story before, I'm sure. The problem stays the same. We want to get that insight. This is our goal. This is why we're doing it. Okay, so based on this and based on the very intensive design work we've done so far, we can create a reference architecture. My reference architecture. There are many like it, but this one is mine. And because we're now cool and trendy, we're going to call it a lake house instead of a warehouse. Fine. I'll bring in my data sources. Oh no, I've got data sources on the right as well, not insights. I copied the wrong box. Silly me. That should say insights. You get the idea. My reference architecture is already wrong. But here is my reference architecture. Albeit wrong, but hey. Now, if this is going to be our reference architecture, we're going to gain that power. I think this is a good starting point. Very, very simplistic, no doubt. But, you know, this one's mine. This one is Microsoft's. Theirs is much prettier, right? Really pretty. I mean, look at all those things go. Now, just to give you full appreciation of how pretty this slide is, this is not a GIF. Some poor person has animated all of those dots flowing up through this diagram. I stole this from Patrick LeBlanc when we were over in Belgium before Christmas, so I thought, yeah, I'll steal that slide because, you know, could this be a reference architecture? Maybe. Just a bit of fun, but hey, Microsoft obviously, you know, copied mine, and they obviously did it correctly, and they made it prettier. But we're not interested in pretty. We're interested in functionality and having the right label on your box on the right-hand side. Let's move on. What's our primary design focus then? To make it look pretty? No. There is, of course, amongst this Venn diagram that I put in front of my customers, a perfect solution. I think I've seen it a couple of times, but we have to whisper about it, otherwise it goes away and someone changes their mind. But that perfect solution does exist, but we don't live in a perfect world. We don't live in a world of ideals, so we have to be pragmatic with our design. We have to, in my experience, pick 3 of these things. We can't have all of them straight away. We have to think about a minimum viable product, certainly. So take this Venn diagram and use it and scare some customers with it. Some customers will squint and say, hey, you've forgotten security. Say, no, security should be baked in. It's not a design focus, it should just be there. But anyway, let's not digress. So with my ramblings and my silly sense of humour, let's say that our design is done. For now, we've got a reference architecture. You saw it, it was brilliant. We now need to actually go and build something then. Let's get a little more practical, a little more hands-on using PowerPoint. And let's think about how we extract that data then. Let's extract that data from somewhere. We start by understanding the requirements of what we're going to do. We have some data in some form. We want to understand how it's structured. We want to understand where it is stored. What is the database technology that this data is going to exist in? We might want to find out if that data is going to be pushed to us, or we're going to pull it. We're going to do something with polling, maybe. We might want to understand if it's going to be batched, and we're going to go and fetch it on some sort of recurring schedule. It might be in some sort of speed, streaming, near real-time pattern that we have to go after. There might be a scenario where we're dealing with public endpoints and private network connections. Probably. There's almost certainly going to be some sensitive data in there that we might have to handle and do something with. Maybe, probably, possibly. And then we might want to understand our data volumes. How big is it? Not big, big, bigger, more big. It's relative, of course, but it might help inform our design. So if these are all the possible requirements we could have to extract and to ingest that data as a starting point, let's think about what we could do. Specification version 1. The customer says, yes, here are your requirements. I have some flat files. It's coming from some local storage. You need to go and pull it. It's going to be a batch load. There's no PII in there yet, no sensitive data of any kind. We're going to use some public connections, and our data volumes, they're quite small to begin with. Say, fine, I can design this, I can build this. Solution version 1, on-premises in Azure, some CSV files. I'm going to land it in some storage in Azure. I'm going to use Azure Data Factory to do it. We could do. I'm going to deploy a self-hosted integration runtime to allow that data factory to reach down to that on-premises network. And I'm going to create a pipeline with a copy activity to bring that data in. Based on those version 1 requirements, solution number 1, done. We could do this. This would work, right? Is this okay? It's okay, trust me, it's okay. But, of course, there's a problem. The requirements change. The customer says, wait, I've now just realized that my data's got more bigger, more big, more large. It's okay, that's fine. We can deal with this. We think about our architecture. What should we do? I've got more CSV files now. I've got lots more data that I need to ingest. That's okay. We can scale out our integration runtimes. We can have up to 4 nodes per integration runtime endpoint for that self-hosted IR. It will fail over, it will load balance for us with those copy activities. We register them with our data factory, and we copy and we ingest that data. Fine. Requirements updated, specification version 2, solution version 2. Done. This could work. We could do this, right? Guess what? The requirements change. The requirements change. The customer says, actually, I don't want to use public endpoints anymore. I want to use private network connections. Private network connections because, I care about security. I want that extra layer in my solution. No problem. Specification version 3. We look at our architecture, think, what do we need to do here to deal with this one? The answer is we actually need to move those integration runtimes to the other side of the network boundary. They now need to exist in Azure. Specifically as well if you're using an Azure Express route. Is anyone using an Azure Express route in the room? Is anyone rich? The people with their hands up are all rich. Just kidding. We need to have that express route in place. We need to have those virtual network connections in place to give us that bridge between our on-premises network and our Azure network. We have those virtual machines that sit on that Azure side of the boundary, and we can do this. Biggest mistake I see with customers that have express routes in place, they still put the integration runtimes on the wrong side of the boundary. which means that those IRs will then still try and go out over a public connection, not using those express route circuits. One to be mindful of. Fine, we can do that, but the requirements change again. The customer says, hey, I don't just have CSV files now, I have some relational databases as well and things that I need to interact with. Maybe SAP. Fine. We can update our architecture once more. We could say, yes, let's make an assumption that those relational database stores, they exist on the on-premises network. We can access them via the same networking and things. You know, we will get some help from our networking engineers to support us with that. Those IRs could go and interact with those sources and ingest them. We could, depending on where they exist, use now a VNet-enabled integration runtime and manage private links within our data factory. Again, it's where the lines of a data engineer get blurred with a networking engineer because we need to figure out how to actually connect to these things to do the data engineering work as well. But yeah, we could do this. You notice that I've put an inter-systems cache database on there quite deliberately because this has caused me a lot of pain once upon a time for a customer that had one of these. And I had to use ODBC drivers on my integration runtimes to connect to that. Lots of fun. Not. But hey, we could do this. Solution version 4. This could be how we create this end-to-end solution. Guess what? The requirements change. The customer says, hey, I've got some IoT devices, I've got some sensors, I want some near real-time data. Near real-time, again, it's a bit kind of relative. If you talk to an investment bank about what real-time means, they give you a value in milliseconds and latency becomes very important. You talk to a retail customer, they think real-time is about 5 minutes. So it's relative like big data, but hey, we'll go with the fact that we've got a IoT source and we want to bring that data in as a stream. No problem. We go back to our solution. We say, yes, we have our devices. They're out there in the wilderness. We might deploy an Azure IoT hub to deal with that. And we might use Azure Stream Analytics to take that data from that IoT hub. We could use an Azure Event Hub in here instead. Differences, roughly speaking, between the IoT Hub and the Event Hub. One will give you that device level security. The IoT Hub will also allow two-way communication with that device if you need it, but you know, lower level requirements there to think about. But for simplicity in this talk, we'll say yes, we're going to do that. We'll use that IoT Hub and we'll bring it in. Last one, I promise. Version 6, the requirements change. The customer says, oh, actually, I just realized I've now got some PII, some sensitive data in there that I need to deal with. GDPR is a real thing, right? So we go back to our architecture, and on our CSV files, look, very subtly, we've now got some redacted data. Look, how subtle is that? I love drawing pictures, it's great. How do we deal with that as part of our ingestion when we extract that data if we're building this in Azure? Well, the pattern that I favor, that I've adopted a few times now, is that as part of those ingestion pipelines, for that sensitive data, I will divert it to a privacy store. A database, doesn't have to be SQL, but whatever you like, that sits there to deal with those sensitive values. We understand through some sort of classification and inspection, some profiling maybe, where those attributes actually exist in our data source. And at the point of ingestion, we divert them to that privacy store. They stay there, and from that privacy store, we then provide an anonymized value that can go back into our storage. So we can still report on those sensitive values, we just don't know what they actually are. It means as well that if a customer or an individual invokes their right to be forgotten, we can just remove them from that privacy store, disconnecting their anonymized value from their actual personally identifiable value. So this is a pattern that can work quite well. So we could do this. So let's stop there with version 6 of my solution. Let's bring it back to our overall architecture. We're going to build this thing end to end, right? So we take what we've learned and what we've done and what we've evolved. We say, yes, this is how I'm going to extract my data. Do we need to do all of those things? Do we have all of those problems that I've described? It depends, absolutely. But to give you a feel for it, obviously, in the time that we've got today. So we say, yes, fine. I've extracted my data. Let's move on then. We've done some design work, we've done some extract work. Let's think about transforming that data. What are we going to do to transform it? Well, to break this down, let's think about compute and storage. And I'm going to do these slightly out of order. We'll deal with compute first. But when we think about that compute, and just so we're all on the same page here, very simplistically, we have some work. We want to do something with it. We have some compute that scales up. It gets bigger to deal with those volumes of data. We might have some compute that scales out a lot. We might have some compute that only scales out. Or, as typically is the case, we have a sweet spot. We scale out a little bit, we scale up a little bit, we do some performance tuning and things. So, just so we're on the same page, we need to think about when we're scaling up and when we're scaling out, because this could become important in our solution. Fine. If we think about that type of compute, we now have everything as a service, right? In Azure, we could use platform as a service resources. We could use infrastructure as a service resources. We could, if we really wanted to, have SQL Server sitting on a virtual machine in Azure and do everything that way. We could. Now, I don't like managing infrastructure anymore, so I'm obviously definitely going to go down the left-hand path here of using that platform as a service tech, and certainly everything in our extract pattern and process is going to be using those platform as a service technologies. So, let's just be clear about that. Fine. If we're going after those platform as a service resources in Azure, what should we use? Stephen, what should we use? Good question. I'm teasing. A few wrong answers on here, obviously kind of deliberately. Should we use Azure Data Lake Analytics? Who dedicated 2 years of their career to blogging about USQL and doing things with Data Lake Analytics? Because it was really good. It was a fusion of T-SQL and C#, which are my two favorite things. Should we use that? No, sadly not. Not to be, I'm afraid. Now, ultimately, on this slide, in most cases, it depends, we end up with two options. Synapse or Databricks? Who's for Synapse? Show of hands in the room. Who's for Databricks? Maybe about 50-50 actually in the room. Maybe. Now, ultimately, it comes down to taking the red pill or the blue pill. What was the quote from the film? Do you want to see how deep the rabbit hole goes, or do you just want to wake up in your bed in the morning? Whichever one wakes me up in my bed in the morning, I think, at this point. But, you get my silly sense of humour. Did you know Keanu Reeves is very critical to our industry? Not just in this reference, but did you also know he was one of the original founders of the Lake House? Good. Saturday morning jokes. Who knew? Keanu Reeves, data engineer at heart. Let's pretend we take the red pill. We take the red pill and we use Databricks for our compute on this occasion. I get this question all the time from my customers, which do we use? And we can try and break it down between performance, cost, cluster management. Do we like Synapse Spark sessions? Do we like Databricks clusters that we provision and obviously have a little more control over? It depends. but we can try and figure that out. Fine. Let's move on and think about storage. Now, storage is kind of the easy one at this point, because in Azure, you pretty much now have one option. This is good. I like it when there's only one option. Something that's an abstraction over our Hadoop distributed file system. And yes, we deploy a storage account. We probably give it the hierarchical namespace capability, so we can create a data lake. Do we like data lakes? Yeah, of course we do. Good, so we've got one option for storage. That's easy. We don't need to do anything else now. Architecture done. Of course not. My first data lake. Beautiful, right? Beautiful. We carve it up. We talk about taxonomy. Do we talk about taxonomy? What do we put in here? In and out. We have some magical path for our plumbing. The data comes in, the data comes out. You've heard all the analogies, data swamp, and all these bad things. No, we don't do that. Please don't do that. It is magic though, really. But of course, we do something better. We create something maybe like this. It depends. Always it depends. But the goal here is curation. Now, I've worked with lots of customers. They all call these layers slightly different things. We have modeled and trusted and conformed, and I don't mind what that top level label is, as long as we take our data lake, whether you do it maybe with separate data lakes, maybe whether you do it with containers to support your security model, entirely up to you. But of course, the goal is curation. And in that taxonomy, if we define clearly what each of those layers in that data lake is for, we should be okay. We can keep that structure. We might have partitioning for our clean layer. We might do some append or overwrite in that aligned layer. Maybe. We might start thinking about a Kimball style fact and dimension schema in the conformed layer. Again, entirely up to you. Do we need all of these things in this picture? Probably not. Now, we try and simplify things in a medallion architecture, as we like to call it, with bronze, silver, and gold. Do we like bronze, silver, and gold? Is that a nicer way to describe it? It's fine. We want to think about the file format, how we're actually going to store this stuff in each of these layers. In landing and raw, do we just take whatever file format we've provided from the source system, and then actually do we standardize around CSV and Parquet? Probably not. Keanu Reeves wouldn't. Keanu Reeves would obviously use the Delta Lake. We're a big fan of the Delta Lake now, right? Any fans of Apache Hoodie or... Oh, my mind's gone blank. What's the other one? Iceberg, thank you. Any fans of Iceberg and Apache Hoodie in the room? No. One at the back. Maybe he's teasing me. But of course, yes, Databricks have now given us this open source storage format. They've now open sourced all of the capabilities of the Delta Lake, which means that in our distributed data lake storage, we get this ACID resilient transaction level processing over the entities that we create. It's still Parquet underneath, but we now get a transaction log. In our SQL database of old, we would have an MDF file, an LDF file, one for the data, one for the transactions. In our data lake, it's the same thing. Just at a table level, we get a Parquet file for the data, a JSON file for the transactions. It's all good. So almost certainly now we will use Delta Lake to store and to structure that data. Fine. We bring that in. From our ingestion, we add in our Delta Lake. We give it the compute of our choice, the red pill in this case. We also maybe add in some other data factory pipelines to support the orchestration of this thing. In our solution, we have Data Factory, Data Lake, Databricks. All three things that start with data, so seems like a good choice. Let's move on. What else do we need to do here? We need to do some loading, right? Do we do still loading still? What are we actually loading into? Let's think about that then. In my overall architecture that I've got so far, it's very pretty, I know. Let's move everything to one side for a moment, and let's think about that prepared layer that we've got. You might not need a prepared layer, but let's go with it for now. And we say, yes, from that prepared layer, what am I then going to build beyond that? Do I need to build anything? It depends. We might have a SQL serving layer. We might. We might have a semantic layer, or maybe even some data virtualization if you're cool and trendy. We might have some visualizations, almost certainly. You know, the original goal that we talked about when we designed this thing earlier, we still want to get that insight. We still want to maybe do some things in here. But how do we decide what we actually need now? What requirements have we got to guide us with this? Well, we could start thinking about the personas of the people that we want to serve this data to, or to give it to them. We might have some data scientists, some technical people, some developers. We might have some analysts, maybe. We might have some business users, some business analysts. We might have some managers and execs. You can tell they're managers and execs because they've got ties on it. All good. If we have these different personas, this is going to inform what we actually need in terms of our requirements. So this could certainly help us. Other things that we could do here, or things that I like to think about, because we're refining that data, we could say that actually in our data lake, maybe we keep everything, maybe 10 years of data or more. You know, data retention becomes a factor. We might say in that SQL serving layer, we only have 5 years of data. We don't need everything in there. You know, we want to be cost efficient with what we're building and what we're designing. Maybe in that semantic layer, we only need year-on-year reporting, so we just keep 2 years in there. We could do this. It depends. And of course, based on those requirements, we might then want to start teasing out what service tiers we actually use within Azure. Do we use a hyperscale SQL database and maybe pass through that data in a direct query model via analysis services? Do we need to persist that data in every single one of these layers? Probably not. You know, repersisting that data and copying it, that takes a lot of effort. We don't want to do that. We want to keep it where it is, but things to think about. Do we use Power BI Premium? Do we forget that semantic model altogether? Maybe we don't need any complex KPIs and things. We don't need to put a load of DAX into what we're actually visualizing. We can just serve it straight up to the users. Now, of course, in doing that, we have to make sure they understand how to write that SQL to join those tables together. They might have to do some of that work. Yeah, it depends. Maybe we forget the serving layer and we just load everything straight into that analysis services model or into our Power BI Premium model. Maybe we do something with Polybase to allow that analysis services model to get loaded very quickly because we can use Polybase to parallelize that loading. Maybe. You know, again, more technical patterns we could explore. It depends, but we could do this. Maybe we now actually, because again we're cool and trendy, we just use serverless components. Serverless SQL from Databricks, still limited region availability in Azure, still in public preview, but still good. In Synapse, of course, we have that serverless capability there as well. We can now leave that data in the Delta Lake, do an open row set with a bunch of views. We can parse that Delta table. We can serve it straight to our visualization tools if we wanted to. We don't need that traditional SQL analysis services stack. It depends. So to think about that, and if we bring it back to a picture a bit like this, and we say, yes, fine, I've got some source systems, I've got a Delta Lake, just a kind of an icon level here. I'm using some flavor of Apache Spark, red or blue, we don't mind, it's just Spark. And then we put in this dotted line, and we could actually say, if we wanted to think about this a lot more broadly, that everything on that left-hand side of that dotted line could be cloud agnostic. Is this a multi-cloud solution we're going after? It could be. We've got these things available now in AWS and GCP as well. So it could be. We're probably going to be working in Azure though, so it's fine. So let's just kind of summarize and think about then how we might consume that Delta Lake. Maybe we do it directly. Maybe we've got some Power Query that will parse those Delta tables for us. It's possible. I've seen people that have done it. We take that traditional serving and semantic layer approach. We just serve it from the SQL engine. We bring in Synapse. We do it via the SQL endpoints, via the Apache Spark pools we could do. We've got a Spark connector in Power BI. We could do this. We could, of course, take the red pill with Databricks and serve it that way. Options 1 to 6. Who's for option 1, serving it from the SQL database, by way of show of hands in the room? Yeah? Oh, I'm going to put a it depends answer on here as well, of course. Who's for option 2, with analysis services and a good semantic layer with lots of complex KPIs and things? Yeah, maybe. Option 3, via the Apache Spark engine within Synapse? Maybe. Option 4, with some SQL endpoints, either dedicated or serverless? Yeah. 5, Databricks? Ooh, not so popular. Interesting. And then option 6, do we do it directly from the Delta Lake straight into Power BI? Tricky one, kind of a hard one we could do. Who's for option 42? Yeah, of course, of course. So we come back to our picture. There's lots of things there, lots of things we've explored. We put some more icons in here. We say, yes, fine. We have some serving layer, maybe some semantic layer, some visuals. The goal, the problem still hasn't changed though. We're still trying to get insight from this data. Do we need all of these things? It depends. Are we done there? Is that our architecture finished? Is that end to end? Yeah. But there's more. We could do so much more, couldn't we? Yes, Paul. We could, if we wanted to, serve that real-time data from Stream Analytics to the Power BI dashboard. We could have some live dashboards going in there from that real-time data. Great fun. Very gimmicky, but great fun. We could do that. We could extend our picture to include that, from ingestion straight to the visuals. We almost certainly need to wrap all of this in a nice DevOps veneer. Do we do CI/CD? Do we do source control? Yes, Paul. We do source control, right? Now, of course, you can't have DevOps without ops. We care about those operational people, right? Those managed service people that have to look after all this stuff that we've built. Or do we just throw it over the fence and say, there you go, crack on? No, we care about them. We want their help. We have to bake in some logging and monitoring and stuff in here, right? We do this, right? In Azure, we have application insights. We have log analytics. Now, in pretty much every other icon that's on there, you can go into the diagnostic settings and you can output that telemetry to log analytics. You can write custo queries, KQL. Do we like KQL? A little bit. Tough crowd. I like KQL, I'll say it. It feels a bit strange writing SQL and then kind of writing KQL, but it's okay. So we care about those operational people. What else might we do here? Thinking about our design. Maybe we're designing for cost. Maybe we're working with the public sector. We might bake in some cost management. If we think about that semantic layer, you know, in Azure analysis services, that's an expensive resource. We don't just want to have the biggest service tier available because that offers the most in-memory capacity for our data. We actually have to look at the data volumes at this point. So things I've done in the past for other customers is we will have functions and things that will go into that analysis service instance, look at the fact table, dynamically create the partition in that fact table for the next day, load it, delete the partition from 2 years previous. So we keep that sliding window. We keep that data in that analysis service instance small. Because it's expensive, we don't want to go to the next service tier. We're pragmatic with it. We could do that. What are we missing from here? What haven't we talked about? Metadata, yeah, we'll get there. Don't rush me. Security. Security is important, right? We need to deal with security. We need some Azure Key Vaults, possibly. Do we like Azure Key Vault? Yeah, of course we do. We might want to deal with some managed identities and things in here as well. We used to use a lot of service principals. Now we can use managed identities a lot more. Managed identities in the context of our data factory will allow them as trusted services to connect to that storage regardless of the firewalls and things that might exist at that storage layer. So, things there that we need to consider. We need to add some more icons in here for the networking. Networking. The number of times now where I've had to take my data engineer hat off and put my networking engineer hat on and go and say to the IT teams, yes, I've got a Databricks workspace. Yes, I've got some clusters. How many IP addresses can I have, please, for my Databricks clusters? Because if you deploy this using the defaults, Databricks, I think, will provision a VNet with something like 32,000 IP addresses. On a corporate network, when you've got peering and express routes and things like that, I went to an IT team, I said, okay, I want 32,000 IP addresses. It's like, nope, that's far too much overlap. You cannot reserve that much address space on our network for your Poxy data project. I was like, okay. I said, how many can I have? They said, 5. So, right, I can work with that, but your solution's probably not going to run very quickly. So, again, this becomes painful. We have to put on that networking engineering hat to deal with some of this stuff, unfortunately. What else might we do? Metadata, yeah. Metadata. Oh, there we go, thank you. If you're me, I would wrap up all of that orchestration with a metadata-driven framework, one which I badly need to go and update actually, because .NET 3.1 is now no longer on long-term support, so I need to go and update all the libraries in there to .NET 6. It's on my to-do list. But in all of that orchestration and dependency chains that we might have to go and create to drive this solution, we're limited by 40 activities per pipeline. If we're creating some complex dependency chains, we need to deal with something in there that will allow that to happen. We might have, lastly, some regional integration runtimes as well. Maybe we don't want to use the auto-resolving IRs that Data Factory gives us. There's a whole other level of detail in here of what we could build. Are we done? Is this enough? Do we need any more icons on here? Who wants to play the Azure icon game after this? So should we build a data platform solution like this? Who's for yes? Ooh, no one. Scary. Who's for no? Who's for it depends? Yeah, of course. So in obviously the 50 minutes and the time we've got today, this is how I wanted to describe this for you guys. Trying to build this thing end to end. It is hard, it is complicated, it does require a lot of moving parts, a lot of plumbing. Understanding the details of what every single icon does on that screen is hard. Having that massive breadth of knowledge now and trying to equal it with the depth of knowledge in those key services that we have to go after, it is hard. But hopefully through this journey, through the great design work that we did together up front, this is how we could create a solution. So with that, I will say thank you very much for listening. Do feel free, of course, to go and grab a PDF of the slides and things from my GitHub. And I really would appreciate your feedback via the QR code from the event hosts. Thank you. We have 4 minutes for questions if anyone wants to, or reach out to me on LinkedIn or Twitter, I really don't mind. Any questions from the online folks? One coming in a second, okay. Stand by. Is it going to appear over here for me? Can we throw the catch box at anybody in the room? Come on, Stephen, quicker. Wow, that's a big question. Everyone can see this, right?
No, so you have to read it. Or
Yeah, sure. Invisible. We've got a very complicated and complex scenario, as we all do. What is the best architectural approach to implement such a project? It depends. I think this person messaged me on LinkedIn or Twitter. Let's take this offline, and we'll draw some pictures on a whiteboard or something. I'd love to. And we'll kind of explore this, particularly as you've got data coming in there from Dynamics 365 and SQL Server. You know, do we break out the Dataverse and do things there? We could do. But yeah, let's take it offline and we'll do something to answer that question fully.